Hi students, today's video we're going to learn about factor theorem. Right, before we touch on what factor theorem is all about, let's do a recap on what are factors. So let's go back to your younger days. All right, when you first encounter this word factors. All right, can you close your eyes and try, go back to the day. I hope it's not a nightmare. All right, when the teachers explain what factors are and what multiples are, do you recall? All right, but today we're going to recap what factors are. Let's start with this number, a simple number that say 12. Right, you would have remembered something like this. 12, you can actually break it down to 1 times 12, and you can break it down to 2 times 6, and then 3 times 4. What else? I can't have 5 times, cannot be 6. I think that's about all right. And then the teacher would have told you that, so hey, the factors are of 12 are 1, 2, 3, 4, 6, and 12. Right. Okay, so what is so special about these factors? Right, what's so special? So if you were to take 12 and divide it by 2, let's see what happens now. Or you take 12 divide by 6. All right, and so on and so forth. What do you realize? What do you observe? Not realize. What do you observe about the remainder? Yeah, the remainder is equals to 0. Right. So in other words, 6 is a factor of 12. Right. So 12 is exactly divisible by 6. So therefore, if 6 is a factor of 12, then you will get remainder equals to 0. Okay, because 12 will be exactly divisible by 6. 12 will be exactly divisible by 1. 12 will be exactly divisible by 3. Exactly divisible by 4. Exactly divisible by 6. Exactly divisible by 12. All right. So if something is a factor of something, then the thing divided by the factors will give you remainder equals to 0. Right, let's give you an account, a number which is not a factor of 12. Let's say this number 5. Okay, so if you take 12 divided by 5, let's see what happens. Yes, can you see that you actually get remainder 2? You don't get remainder 0, you get remainder 2. So therefore, 5 is not a factor of 12. Right, so let me summarize. So to be a factor of something, right, the something must be exactly divisible by it. Okay. All right, so hopping on what we have just learned, right, we can actually apply it to polynomial. So it's actually quite simple. All we need to understand, if you look at this here, there are 2 arrows, right? One is this arrow going forward. What this arrow going forward means is that if in the questions, if in the questions you're told that if you are told in the questions that ax minus b is a factor of a polynomial. What am I doing? I'm just rewriting the thing, right? Okay, if you're told in the questions that ax minus b is your divisor, right? And your divisor is a factor. Your linear divisor is a factor of the polynomial, then the remainder. Remember, this is how we find remainder in the remainder theorem. The remainder will be 0. All right. So the other direction, it can also happen the other direction. It means that if you are told that when the polynomial is divided by a linear divisor, and if you are told that the remainder is 0, then we can safely say that your ax minus b is a factor. Right. Remember what we've learned earlier on? If something is a factor of something, then the remainder is 0. Okay, basically it's just that simple only. Right. If you're told the remainder is 0, that means the divisor is a factor. And if you're told that a divisor is a factor, then you can conclude that the remainder will be 0. So that's factor theorem. That's it. Simple. Right. So we're going to do 2 examples. The first one is just the direct applications of the factor theorem. Okay, so how direct is this direct application? All right. So let's look at the question. So you are told that x minus 2 is a factor of a polynomial. Right. So if x minus 2 is a factor, what is the conclusions that you can make from here? Ding, 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 ding. What's the conclusion? Yes, if x minus 2 is a factor, it means that your remainder will be equals to 0, right? So what we need to do now is to find the remainder, correct? We need to find the remainder, and we need to show the remainder equals to 0. So if remainder is equal to 0, then we can tell the whole world, yay, x minus 2 is a factor. Right, so this is what we're going to do. We're going to find f of 2. Why f of 2? Because we're going to let x minus 2 equals to 0, right? And we're going to substitute x equals to 2. That's how we get f of 2. Right, so what does f of 2 means? F of 2 means you substitute all the x, the variable x with the number 2. So this is what you get, 2 squared minus 3 bracket 2 plus 2. So let's see what happened. Let's see if it gets 0. That will give me 4 minus 6 plus 2. And yeah, hey, we get 0. We get remainder equals to 0. Right, so let's do some explanation. So we say that since f of 2 equals to 0, or since remainder equals to 0, okay, since remainder equals to 0, using factor theorem, it's good to write down using factor. It shows that you're understanding, and it shows that your understanding of what factor theorem is, and you make your answer more atas also. So since remainder equals to 0, using factor theorem, x minus 2 is a factor of fx. Okay, just this simple. Right, let's do the other one. All right, so I need to find f of 2, substitute into a second polynomial, which looks a little bit more complicated, but no worries. Just do it diligently. And you just use a calculator lah. This one you don't really have to trouble yourself. If you want to, you can go ahead. But I'm just going to use lazy people like me. I'm just going to, when we say lazy, I'm just going to use the calculator. But if you want to exercise your brain a bit, then you just use some mental calculations. Okay, negative 16. You get negative 16. So what does negative 16 tells you about the remainder? Yes, negative 16 is not equals to 0, right? So the conclusion is since remainder is not equals to 0, right? So then you can't use factor theorem, right? You're not going to use factor theorem, okay, please. Because the remainder is not 0. So since remainder is not equals to 0, hence x minus 2 is not a factor of fx. Okay, so this is how you can test out on the applications of the theorem. Right, here we are. We're going to do a not so direct application, but actually it's not that difficult also. Right, let's look at the question. So the keyword is this polynomial is exactly divisible by this guy. Right, so exactly divisible. So exactly divisible, what does it mean? What does it mean to you in the world of mathematical terms? What does exactly divisible mean? Yes, it means that the remainder will be equals to 0. Right. So if your remainder equals to 0, can you recall what we have learned earlier on using factor theorem? Yes, factor theorem says that if your remainder equals to 0, then x squared plus 2x minus 3, right, will be a factor of your polynomial that's given there. Right, but recall also that we can't actually, we can only apply remainder and factor theorem on linear divisor, right? On linear divisor, right? So what you're given here is not a linear divisor. What you're given here is a quadratic divisor. So how are we going to change your quadratic divisor into linear form? Let's start with the letter F. Yes, you factorize it. Okay, you factorize your quadratic divisor into linear factors. Okay, so this is what we're going to do. So your x squared plus 2x minus 3 can be factorized into, okay, right, and then let's start off with your dividend, which will be equals to the two linear factors there, multiply with the quotient. And since we're using factor theorem, the remainder will be 0, right? So there's don't need to write plus 0. Okay, there's no need to write plus 0. But we all understand that it's plus 0 because the remainder equals to 0, right? Okay, so you have two unknowns here. You have your unknowns A and your unknowns B, right? So how do you find these two unknowns? Yeah, you need two equations. All right, obviously you need two equations lah. So we need to generate two equations, solve them simultaneously. Then you can find the unknowns A and B. So how do you generate the two equations? So let's go back and examine your divisor again. Can you see the two linear factors there? Right, so I'm going to separate the screen into with a vertical line like that. First one, I'm going to let x plus 3 equals to 0. And then the x will be negative 3. Right, so why do you let x plus 3 equals to 0? Because if x plus 3 equals to 0, then 0 times x minus 1 will be 0, and then times q of x will be 0. Anything times 0 is 0. Remember, anything times 0 is 0, okay? Right, so that will give you a big fat 0 on the right-hand side. Okay, so we're going to do the substitution now. So you will have 2 bracket negative 3 power of 3 plus a bracket negative 3. Make sure you substitute correctly, because just now I make a big mistake because I have not eaten my breakfast. That's why I'm hungry. I substitute the first x term to be negative 3, and then the second one is negative 2. I don't know how the negative 2 comes about. Okay, never mind. So you just need to be careful when you do the substitution. All right, so 2 bracket negative 3 to the power of 3, then minus 8 bracket negative 3. Okay, also give you negative 30. Wait, let me see my calculation. Did I do wrongly? 2 bracket negative 3 cube plus a. Okay, you still get negative 30. Right, so here will gives you negative 3 times negative 3 will be 9. So it gives you 9a plus b equals to 0. So 9a plus b is equals to 30. I'm going to use substitution method. So I'm going to make b the subject. So b equals to 30 minus 9a. Call it equation 1. Then the second equation, let's use purple color. I like purple. We're going to let x minus 1 equals to 0. So we're going to substitute x equals to 1 into your dividend. Right. Why is your right hand side will be a big fat 0? Okay, let's substitute. Not substitute, let's simplify it. 2 minus 8 will be negative 6. Negative 6, you get it over to the other side, will be positive 6, equation 2. Alright, so we're going to sub 1 into 2 and see what happens. A minus 9A will be negative 8A, negative 24. A will be 3. So after you found the values of A, what do? Yeah, of course, you're not going to put it in your pocket lah. Anyway, it's not valuable. So you're going to substitute A equals to 3 into equation 1. And B will be 30 minus 9 times 3. So 30 minus 9, 30 minus 27, that will be 3. Oh, so A is 3, B is 3. Alright, so we found the values of A and B. However, we have not completely answered the question. Why? Because there's still this part here that we have to answer. Hence, write down the other factor. Because this is a cubic polynomial, so for cubic polynomial, right, you would have 3 factors. Okay, you have 3 factors. Right. So now we have found the values of A and B. You can just plug inside there. Plug inside your plug inside your polynomial. Okay, so actually there's no need to use long division, you know. Some of you may be very tempted to go and use long divisions to find the third factor. Okay, you actually don't have to. You can just simply do it this way. You see, we know that your last factor will have to be a linear form, right? Have to be a linear form. So we just let this guy be ax plus b, okay? Right. So how do I get this first term? You get it you get it by taking x times ax, right? So that will give you ax cubed. So ax cubed is equals to 2x cubed. So from there, a is equals to 2. Okay, you get it? And then you take 3 times negative 1 times positive b. That will give you negative 3b, right? That will be equals to your last constant term here, which is 3. From there, your b is negative 1. So therefore, can you see that you have managed to find the other factors? So the other factor is just 2x minus 1. Okay, that's it. That's simple. You don't really have to use long division. Okay, so this concludes the whole video on the factor theorem. And how long did we take that? 17 minutes. Oh, coming to 18 minutes. So not bad lah. Okay, let's congratulate ourselves. Well done, well done.